A rapid mix right here. We'll add our alum and our carbon, powder activated carbon. We've already added our potassium permanganate upstream. We have a small pre-contact basin to get contact on there. So that's come in here. There's a rapid mix. High mix energy. And you can see we step it down, so we have quite a bit of mixed energy here. We step it down to the next section that's a little bit less, and then kind of a small horsepower on the end where we impart just a little bit of mixed energy just to keep those flock particles growing. So you can really, it's a good demo. Actually, we'll go out and see the line softening bases and really see how the flock particles grow. And then here we have clarifier. Clarifier. We actually have a vacuum system that goes across and collects solids every few hours. All the solids will collect. We're making the flock particles here, make them big enough to sell to the bottom of this clarifier. Clean water will go up the top. All these little white boxes you see here, that's our settling tubes. So we're stuck with our footprint here. If we had more space, we wouldn't have these. We just have bigger clarifiers. But we can put these settling tubes in, so instead of having to settle this whole 10 feet of the clarifier, you don't have to settle that far with the settling tubes like this, so you're decreasing the space you have to settle. Okay. So that's another thing that we happen to have here. So then we go into our second phase treatment. So there's a trough that feeds lime. It comes all the way through here, drops lime into these tanks, and we just repeat this same process really, but we have different chemistry. So we're adding our lime to drive the pH up so that our calcium and magnesium will precipitate out. So we're driving the pH up over 11 in these basins. Then we just repeat the same thing. We have rapid mix, and then we have flocculation chambers. Again, lots of mixed energy, the less mixed energy, and then goes into another clarifier. This is our second stage clarifier, lime softening clarifier. And this lime solids or lime softening clarifier, heavier solids, so we can't use a vacuum system. We have actually a scraper, Clayton chain, scraping to a sump area over here, and all those solids are collected. In the sump area, we do press. We have a plate and frame press here to press out all the water, and then all that used lime, the spent lime, is we have a contract. It gets trucked out to ACS. So, and again, same theme, clean water goes out over the top. So this is one style of clarifier we have. So in another train, we have a circular clarifier. Same concept, all the solids are settled to the bottom, except we have a scraper iron that rotates around and cuts all those solids. Then we move into, a couple of chemicals I did not mention. So our pH is up at over 11. We have to drop that pH back down to make the water drinkable. We bubble carbon dioxide through the water, so we have recarbonation basin. We won't be able to see us behind the closed walls. Then we have filters. So on the way to the filters, depending on the season, we're going to add chlorine for sure. Right now we add chlorine at head. We're doing a pilot that's looking at chlorine after lighting the filters for biological in the future. Right now we add chlorine before the filters. We'll add our polyphosphate before the filters. We have a high pH, and lots of lines have sequestered any leftover calcium there. We don't want to make cement out of our filter beds. And we get a secondary benefit from that, in that we have a corrosion inhibitor in the system with our phosphates. So we have some that will revert back to ortho phosphate in the system and get some additional corrosion protection. We rely primarily on send on our pH for our corrosion inhibition in the system. So we're sending a pH out at 9.2 with a 7.4 water. So that provides most of our corrosion protection out there and keeps us in compliance with lead and copper. But we also have some benefit from the phosphate. Filters, we'll look at those. They're just standard.
You have level 5, right?
I do, but I actually have a little bit more time because my the training I was doing got postponed.
Okay.
So I do have a commitment after that, but I have a little bit more time if you choose. And I can still be done in 25 minutes. So.
Well, we can, we'll take you as long as we can have it, right?
And I'm talking really fast, so I feel under pressure to get done for spend too much time in there. Yeah, we do have control over everything right here. We have certain pumps on.
Adjustments can be made from right here.
So you can adjust most things right here. So if I hit the wrong button, I'll get myself in trouble here.
Was this software developed in-house?
All the programming, we have a consultant that does all the programming.
Okay. So it's certainly tailored to this facility.
Yep.
That's through AU2S?
They actually do that too, yeah. So I'll leave this, but yeah, just know we can control everything right here, and we do have meters kind of throughout the facility, so we have online chlorine meters, online turbidity, and then online organics, both coming in and out. A lot of things are metered on the clock, several times per second, whatever. But we'll go see some stuff. How's that?
Yeah, let's go see some of the real stuff now. See the virtual stuff. So you walk down there, you come down 7 flights of stairs.
Right. I'll talk with you. First stage treatment. So before we get here, our intake station is across the road, right on the river. We pump the water from there into this facility. As soon as it gets in this building, we're adding our potassium permanganate. And
What kind of a structure do you have at the intake?
what kind of structure?
Yeah, how do you do the intake?
So we have so we have 2 channels going to the river. The water comes in, we have a sump area, a structure north and the south. We have 2 structures that are basically just a concrete room basically with a pump and a screen and a traveling screen. So we're protecting our equipment with a traveling screen all the time. We keep all the big stuff out. So as the water comes in, I guess there's a bar screen. I suppose there's probably 2-inch spacing to keep logs and really big stuff out.
Is it a surface intake?
Okay. But the structure actually goes out into the river a ways, so we're taking from a ways out in the river, so it's not
But it's taking directly off the surface of the river.
It is taking, you know what, we have some flexibility in where we take. I think we have a couple of different options.
So you can adjust where the level of the intake is?
We can, and I don't know the specifics of the intake. I don't know the intake really well enough to. I've been inside of the components of the muscles, and I can't say exactly. I have been told that we can take from different levels.
Okay.
But I haven't seen it. I don't know.
As opposed to having anything along the surface, yeah.
Okay.
So it's down below the surface so that you're not going to get floating logs and things like that.
Yeah, and then we do keep it floating. I mean, we do have the screens on top to keep it floating logs, taking from lower.
Yeah.
And then for all twigs and minnows and leaves and whatever else comes downstream. We have a finer mesh traveling stream that gets sprayed and cleaned all the time. That works in intake stations that really protect the lumps and keep the big stuff out. Our big strainer. So we had our potassium permanganate, started breaking down the carbon compounds, and then we come into our first stage here. We got pre-contact that give it about a half hour of detention time with the potassium permanganate. We have our first stage treatment that's right here. So if you look over there, you can see a couple of pumps in that low area over there. And that's our rapid mix area, that's where we add the chemistry, and that's a very vigorous mixing, lots of energy. And if you look at, this is the flocculation step, so we're starting from the middle. You can see that the motors are bigger there, so we're running more mixing energy. They're a little bit smaller than the smallest over here. And you're able to see the paddle size is smaller, everything is smaller. Happening here. From this flocculation step, we're growing those particles, we're coagulating, we're starting to flocculate here. Those particles will go into our clarifier right here. You can, I guess there's a light there so you can actually see what the clock particles look like. The river water does not look like that, but once we add the carbon and the potassium permanganate, the color's purple and the carbon is black, so those two colors combined make the water not look so appetizing.
If there's a little iron in there,
That is very low in the river, yeah.